Hello students, in this lecture we shall be dealing some basic concepts of solid state physics. So starting with the periodic array of atoms. So we know that in a crystal is actually a lattice plus basis, and by lattice we mean that there are three vectors a1 and a2 and a3 in three directions. So if one is translating in a lattice, so it has to translate with the help of these three integers. So if this is the initial position r, so there is a translation has taken place based upon these three vectors a1, a2 and a3. So it will be the new position will be r dash, and it will be u1, a1, u2, a2 and u3, a3, and these three are the integers. Next is the primitive lattice. The primitive lattice is defined by the volume of these three integers, these three vectors, and there are 7 Bravais lattice. You know that first of all we try with the triclinic one, where none of the sides are equal and none of the angles are equal, and the number of lattices possible is 1. Next is your monoclinic, where also none of the sides are equal, and only difference it has with the triclinic one is that two of the angles are equal and equal to 20 degrees, and we can have two different types of monoclinic lattices. That means either it can be alpha is equal to beta is equal to 90, or alpha is equal to gamma is equal to 90. Then the third type, where none of the sides are equal, are where three of the angles are equal. So you can have alpha is equal to beta is equal to 90, beta is equal to gamma, alpha is equal to gamma 90. So you can have 4 different types of lattices. So these three, the triclinic, monoclinic and orthorhombic, they can be, out of the 7, they can be considered to be forming a set where none of the sides are equal. And we move on to the next set of Bravais lattice. So we start with the tetragonal, where the sides all are equal except one of the sides, and the angles are all equal to 90 degrees. And cubic, we all know, alpha 1 is equal to alpha 2 is equal to alpha 3. All the angles and sides are equal. You can have 3 different types of lattices here, and you can have 2 different types of lattices here. Next we can have the trigonal, where again all the sides are equal, and all the angles are equal. Only difference is that they are not equal to 90 degrees. So the difference between a trigonal and a cubic is although the sides and the angles are equal, but the angles are not equal to 90 degrees, but they're less than 120 degree. And hexagonal, we all know, one of the angles is equal to 120 degrees. So we can have again 3 different types of, we can summarize here. First one group is where none of the sides are equal, and in the triclinic one, none of the angles are equal. In the monoclinic one of the angles are equal, and in the orthoclinic 2 of the angles are equal. And the cubic and hexagonal are where all the sides are equal except with the trigonal case, where one of the sides is not equal. So you can have the 7 different types of this lattice. Then in cubic lattice, we all know that there are 3 sides, 8 corners. Each one is giving 1/8 of contribution. So total number of atoms or total number of sides is equal to 1. And there are 6 nearest numbers, and this is also called the coordination number, Cn, coordination number. And the primitive lattice vector, if we consider it for the case of BCG, it is a1, a2 and a3. They are given as a1 is equal to half into a into either of the 3 of x and yz will be minus. So here the x is minus, the second case y is minus, and the third case z is minus. So these form the primitive lattice vectors of BCG. Similarly, we can also have the primitive lattice vectors of FCC, where the first one will be x and y for the first case, second one y and z, the last one z and x. And the volume of the primitive lattice itself for BCG and FCC is this one. A1 dot A2 received.